In this video, we're going to look at some more examples showing the relationship between an equation and a function. Now remember, a function is a lot like a machine. So here's a machine called our function, f of x. So we have an input. We put something into this machine, and we're going to call that x. And the function, f of x, is going to do some calculations, and it's going to spit out an output. The output is going to be y. Okay, so if y equals f of x, then for every unique value that we plug in for x, our machine will generate a unique value for y. This relationship is known as being one-to-one and must be true for a relation to be a function. But we'll talk about relations in a future video. For now, let's look at a few examples. Let's say we have the linear equation y equals minus 1/2 x plus 10. And this is in slope-intercept form. So here, all we need to do to represent a slope-intercept equation as a function is to replace y with f of x, because we're making the transition y equals f of x. It's just a change in notation, but these two are actually interchangeable. So this becomes f of x equals minus 1/2 x plus 10. Plus 10. This is our slope-intercept form in functional notation of our function. So let's just look at a few more of these just to get familiar with the transition of replacing y with f of x, our functional notation. So the next one we have is y equals minus 2x plus 3. Okay, again, this is in slope-intercept form, so since our equation is solved for y, all we simply do is replace y with f of x. So f of x equals minus 2x plus 3. And that is our function. Not a whole lot to it, especially when it's in slope-intercept form. Let's take a look at another one. Let's say we have 4x plus 2y equals 8. Okay, now this equation is not in slope-intercept form, it's actually in standard form. Since we want to replace y with f of x, that's the whole goal of this, we first need to isolate y to one side, so we have a little bit of work to do. But it's nothing that we don't know how to do. We should be pretty familiar with this. So let's go ahead and move 4x to the other side. So we have 2y equals, we're subtracting 4x from both sides, so we have minus 4x plus 8. And then we can simply isolate y by dividing by 2. So let's divide everything by 2. This cancels, so we have y equals minus 2x plus 4. Okay, so now we have it in slope-intercept form. We have our y isolated, so we can write our functional notation. We have f of x equals minus 2x plus 4. And that's the equation of our function. Okay, so what we want to do is we want to isolate y. We want to solve for y so we can plug in f of x for y. We're just making the transition from using y notation or linear notation to functional notation. So let's look at some more. Let's say we have the equation y equals 0.25x. Okay, not a whole lot to this one. We just replace y with f of x. These two terms are interchangeable. They mean the same thing. This just actually helps clarify what's going on and what's our dependent and independent variable. So we have f of x equals 0.25x. Since we're not doing a whole lot with the right-hand side, we can go ahead and leave it in decimal form. Okay, let's look at another one. Let's say we have y equals x minus 5 over 3. All right, don't worry about the fraction over here. We're not even going to deal with it. We're just going to, this is in slope-intercept form, so we simply replace y with f of x. F of x equals x minus 5 over 3. Not a whole lot to it when we're dealing with slope-intercept form. And let's go ahead and do one more. We have x plus 3y equals 1. Here we have another equation in standard form, so we need to solve for y. So let's go ahead and subtract both sides by x. So we have 3y on the left-hand side, and on the right-hand side we have minus x plus 1. And then we can just divide everything through by 3. These two terms cancel, leaving just y on the left-hand side. On the right-hand side, let's go ahead and split this fraction up. We have minus 1/3 x. I tend to, it's simpler to write it like this than this because we can more easily see our slope right here, where this is a little more ambiguous. And then we have 1/3, so plus 1/3. All right, so now we have y solved for. This is slope-intercept form. Let's go ahead and replace y with f of x, our functional notation. So we have minus 1/3x on the right-hand side plus 1/3. 1/3. And that's all there is to it. Okay, so there's not a whole lot to this video. I just want to get you familiar with using functional notation and how functional notation is actually the same thing as y. This will actually be a little important when we're graphing functions because when we have a graph, this axis is x and this axis is usually y, but we'll be writing it as f of x. And it actually helps a lot more when we're graphing using functional notation because we're going to be given a value of x, and f of x just means the function evaluated at x. So when we're given our function, we're going to plug in for x whatever our f of x is. So it's actually going to be it's going to be more useful when we're graphing, but just get familiar with the notation. In the next section, we'll be actually evaluating. We'll see how we evaluate functions at certain given values of x. So I'll see you soon.